Hey guys, welcome to Code Decode. In this video, we are going to look into the Java interview traps where most of the Java developers like us gets trapped in an interview, gets failed in an interview. These might seem very simple Java concepts, but they are very important when you go for any backend interview at a high level or 3 to 10 years of experience level. I'll give you one example. When I ask the questions like, what will this line do? 90% of the even 10 to 12 years experience people answer that this is going to create a new object in the memory. When I ask this question, I expect some senior level pointers to be added to this one liner code. So many of us just thinks that this creates a new object in memory, which is also right, which is not wrong. But this is what I expect from 1 or 2 years experience people. When this line comes into picture, how a senior level thinks is that this single line hides multiple JVM level operations, and there's a whole runtime story behind it. There's a lot of things being done with this just one line. First of all, when you see a new object is created, that is not the first step. The first step is memory is allocated. The class loading happens if not already in the meta space. Then new object comes into picture. Also, the constructor is not just that called. Initialization happens. Then constructor is called, then method reference happens, then garbage collection might occur later on if it is not anymore used. So let's see what this one line do in the background. So the first thing that happens is class loading, if not done already. Remember, this is happening only once per class, not every time. So before anything else happens, JVM checks the meta space, checks if dot class is loaded or not. If not, then it loads the class via class loader, verifies the bytecode, prepares the static fields, and initializes the static blocks if it is present. So before the object creation, that is when you see this, the first thing comes into mind is new object creation. But that is not what is happening the first. First thing, the class is getting loaded. The user.class is loaded in the memory. So JVM ensures that the class metadata is loaded into meta space before the new object creation in the heap. Now the second thing happens is a new object creation. So now JVM calculates the object size, the object headers, class pointers, the instance variables included, the inherited ones from the parents. Memory is allocated in the hidden space in the heap, and at this point, memory is raw and uninitialized. So it is just a block of memory in the heap, nothing else. Just a set of blocks of memory, and then it is associated with the class metadata that you have loaded into meta space. So this is an association also happens when the object is created in the heap, which is very important because you have created the memory, but you have no clue what are the variables, what are the metadata of that particular class, which is given by a dot class file for you from the JVM. Now the third important thing that happens is, so when you see this line, let me just copy this line first in canvas so that whenever we explain, you have this reference with you. Now, the first thing you thought might have the new object creation, but no, that doesn't happen. Class loading happens. Then the new object creation happens in the memory. Then what you see is a construction call. So no, before the construction call, default initialization happens in the memory. That is zeroing memory. This is a very important concept and you must know. Even 3 to 4 year experience people don't even know about this. So before construction runs, what happens automatically? If the user has ID, name and active field, which is a boolean, then the zeroing memory happens. That is, the memory, the chunk of memory that you have allocated in the heaps initiates with the default values. That is 0, false and null. If the object is custom type, then the default value is null. If it is boolean, the default value is false. If it is integer, long, then the comparatively it will be initiated with 0 or 0.0L or something. So internal memory looks like this now. ID is 0, name is null, active is false. So even before your constructor is executed, which is responsible for initializing these values in memory, even before that, zeroing memory concept comes into picture, which initiates these memory locations with the default values. Now the construction invocation happens with the init method. Now the user constructor is called. First the super is called. Instance initializer blocks happens. Constructor body calls. And suppose if this is a user class with ID 10, then initially with the zeroing memory, ID was 0. Now ID becomes 10. So memory was first allocated, then field was set to 0. Now the ID field was set to 10. Now constructor body runs and says I am in the constructor. So constructor does not create the object. This line with this constructor does not create the object. Object was created even before the constructor was called. The task of constructor was only to initialize the allocated object in the memory. And that is very important thing. Huh? Don't say that this constructor is going to create the memory in the heap area. No, that doesn't happen. The new object is the one which is responsible for creation of the object in the heap. The constructor is only responsible for initializing the zeroed memory allocation block with the proper fields value. Now, fifth thing happens is, yes, now this user reference assignment happens. The user reference is a reference variable stored in the stack frame. It points to the heap memory address. So the heap memory was created with new user. This was then now getting pointed from the stack. So object always lives on the stack. So the right side always, object always lives in the heap, and the reference always lives in the stack. So the right side that you see always lives on the heap memory, and the left hand side, the user always resides in the stack memory. Now the object is properly usable. It is fully initialized. Methods can be called, and JVM tracks it via references. At the end, if by any chance you put this user equals to null, or you put this user to point to different new user heap location, then the old object which is created here with the new user is now eligible for garbage collection, which is not happening immediately. It is the JVM who decides when to collect it and when there is a need to deallocate the memory so that it can be allocated to the new objects before reaching the out of memory error. So objects are eligible for garbage collection but not immediately destroyed. It depends upon JVM when to run the garbage collection process. So this one single liner does a lot of things. First of all, it ensures the class is loaded with all the metadata in meta space. Then it allocates a memory on the heap with this new object. Then zeroing memory concept happens where the memory is initialized with the default values. Then the constructor is called, which initializes those values in the memory which is already assigned. Then assign a reference on the stack for the new object created in the heap memory. And later, if by any chance this is a ghosted user, then when no reference exists, then garbage collection happens when JVM wants it. So this one liner has a lot of things to do, and when you are at the senior level, just don't say this line is going to create a new object. A lot of thing happens in behind.
Hey guys, recently we have launched a course covering an end-to-end full stack application using Angular as front end and microservices and Spring Boot as the back end. Also, we have used Cloud to deploy this application, and we have used CI/CD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is REST, RESTful web services, Spring Boot and microservices for backend, Angular for front end. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also, for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka Server and all those microservices counterparts. Now, this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline, and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links.
Now let's see the second one. I'll copy the code again for you. And let's understand this in deep. So now a very classic trap. Whenever asked what is Java, pass by value or pass by reference, 90% of people say it's pass by reference, because when I change the existing value in the new method, that old method also changes. So there is a trick to this. For sure, Java is always passed by value. It is never passed by reference. The only thing that you pass is actually the memory address, which is the reference to the object. And hence you might see that when you mutate the object, then you see the change. So I'll tell you the mutation at the end, which you already know that the mutation happens to the existing user. I'll first prove you that mutation always does not happen. So I'll try to prove you this, that the Java is passed by value, by taking an example of local variable called as user, and where no mutation happens to the existing user. If it was passed by reference, then whatever be the condition, local or this particular instance variable, always the existing user will change according to many of the people, right? That if you pass a existing user to a new method, it will always change because it is passed by reference. I'll prove you in few minutes it is not the case. Java is always passed by value. The only thing is the value passed is a reference. That is why you get confused over it. Don't put a mind around this. Let me prove you this and then you decide what it is. So let's take an example of this code, okay? This is the code where a new object is created in the heap. This is the exact line which I have explained you 2 minutes earlier, right? And that is why I explained you this whole, that you get inside the depth of it. Now when you call the update method and pass the existing user, the memory address of this pointer where the stack object is pointing is passed, which is also used by this user object, which is a local variable. Remember two things. Since user is a local variable, when this method ends, user is also a hanging object, and this new user new name is eligible for garbage collection when this bracket ends. So remember, this user is a local variable. When the method ends, user is also removed from the stack, and if there is nobody pointing from stack to the heap memory, it is eligible for garbage collection. And you know this, right? This is a basic Java concept of local variable being eliminated as soon as the method references ends. Now, if I pass the existing user to this, should the existing user's name change from old name to new name? Answer is it will not happen. Though with respect to many of the people in IT industry, this might happen that the existing user have the new name as new name because it is passed by reference, but it does not happen. And that's how I can prove that the Java is passed by value. So let's understand one small concept. What is this? This is a hexadecimal memory address represented as 0x100, 0x200 and so on. So I'm going to talk about the memory location in the hexadecimal way with you, okay? So just think of this memory address as the house number you stay at, A100 XYZ Street, Washington DC, whatever. Or the phone number, it is just an identifier. So 0x100 will be the address of the first user or the existing user. 0x200 will be the new user created at this line. So I'm going to always represent the memory address as 0x100, 0x200, 0x300 and so on. Now let's start and understand this code. Sorry, this is copied twice. Let me remove it. So the code that we are executing is exactly what I'm going to keep for a reference for you here. Now let's understand in depth what happens at the first place. What happens here at the line number 1 is already explained. This is going to create one object in heap with this particular right hand side, and one object is created in stack named as existing user, and it is going to point to the memory address in heap with the value of existing user as the memory heap area address, that is 0x100. So existing user do not point to old name or any other string. It actually points or contains the value as the memory reference of the object which is created in heap. So this is a heap. This is a user created in the heap with the old name, and the address of this is 0x100, which is the value of this existing user which lies in the stack. So the value of existing user is 0x100. So only one object at this point of time, line number 1, only one object lies in the heap. The value is going to be 0x100 for the existing user. Now the second line calls update existing user. So what Java does is it copies the value of existing user into the user. So now when update method is called, a user is going to hold the new address or the new value. And what is the new value? that is exactly what the existing user is going to copy into user. So what existing user was having the value is 0x100. So now where the user points, user also points to the same heap area. So at line number 1, this was the case. This was the stack and this was the heap, and this is where the existing user was pointing. Now with line number 2 and 3, you can see existing user is pointing to user. So the user also comes into stack and contains the value what existing user contains, which is 0x100. And that is why I can say that 0x100 and 0x100 both points to the same heap area, which is old name. So your user with the old name holds an address of 0x100. Your existing user and this local variable user is both pointing to the same user object with the old name as the field value. Now both of them points to the same object. Existing user points to the same heap area. User also points to the same heap area. Now in the 5th step, when the user is pointing to the new memory address with the new user new name, then what happens at line number 5? A new object is created in heap with a memory location of 0x200. So now heap contains 2 objects, which is old name and new name. First is at 0x100, the second is at memory location 0x200. Now the address is new address is assigned to the existing user. So where the user was initially pointing to old name object, now the new user or the local user variable is now pointing to 0x200 and towards the new name. So now you have 2 stack variables and 2 heap objects, both pointing to the different heap area. That is 0x100 the old one, 0x200 the new one. So what changed here? Only the user reference which was pointing to the old name is now pointing to the new name. What is not touched at all, what is still remaining the same, is the existing user. So with this point, I can prove you that existing user is untouched and still pointing to 0x100. So when the method ends at line number 7, what happens? The method session comes to an end. The user object, which was a local variable to this particular method, which is the method argument, is getting completely void and removed from the stack. This is a dangling host heap area with the new name, and which will be later on garbage collected. But still, what still lies in the heap area is this old name, which is still having the address of 0x100 and is still pointed by existing user, like it was still doing in the earlier step. So this is why I can say existing user dot get name, you still get the old name. The original object is untouched, and hence I can prove Java is passed by value because the existing user is not touched here. The reference assignment does not affect the caller. Even though the caller is trying to change it, it was not able to because only the memory reference was copied, and when the memory reference was taken away to a new address and changing there, nothing would have happened to the existing user. So Java copies the reference value and reassigns it to the local copy, and hence I can prove that Java is passed by value and not passed by reference. Now where all of you gets confused is a place where you think that, oh, it can be a pass by reference also, because what wrong you do is you mutate the existing object. So let me copy this code reference now, where the mutation happens. Remember, this is where the local variable was changing the memory address or the value. Now here, if you can see, you create a new object with a new user here, okay? So the heap as is having the user object with old name and memory address 0x11. Now if you can see, you are mutating the user object with the set name. This is not a local variable change. This is going to change the existing user memory address. And that is where you get confused that yes, this can be a pass by reference because the existing user is going to change in this flow. So pay attention to this. In the first step, what happens is your existing user is now pointing to old name. There is a heap object created with a user object with the name as old name and memory address as 0x100. The assignment of reference happens that the existing user is now pointing to the heap area. The call method happens that update existing user. This is where the Java is going to copy the memory reference to the user reference. And then both of the existing user and user will start pointing to the same heap area, which is 0x100. So inside the state method, the existing user as well as user at line number 4 is going to point to the same user heap area, that is old name with address of 0x100. Now happens the magic. Now you mutate the object. You mutate the user object's reference itself. So now you set the user's name as new name. Now where is user pointing? To the old name. If you change user's name as new name, this memory reference is going to modify. So since you modify it at the time when both of them is pointing to the same memory reference, then for sure even the old will also change because you change the same memory area. So after the mutation, now object user is now modified with the new name with 0x100, and at this point of time you still keep user and existing user pointing to the same memory address, and you allow both of them to modify the same object. And that is why I say in Java, try to create immutable object. If user would have been an immutable object, you would not have allowed the another user to try and name this from old name to new name. And this is the disaster that happens with most of the senior Java developer in this Java world. So when the method and stacks gets destroyed, the user goes into the destruction phase, but user has already done destruction to your old one because now the existing user is pointing to the new name. So your local variable comes into picture. When the stack destroys, it goes out of the picture, but the damage is done because Java is by default, all the custom objects are mutable by nature. And that is why some objects like string, parse.long, not the primitive long, the wrapper long, double, all these are immutable. Because this is a disaster what happens when you allow two different, even the local user can come and change your memory address. So this is why I can see that it is confusing. You can think of it as pass by reference, but it is not. It is pass by value. The only mistake that you have done is you have made the user as mutable object, and hence any come and going kind of method local argument variable can come and change your existing user's value because you have made the mistake of not making it immutable. So the final result is the caller sees the change. Mutation affects everyone who holds to the reference. Now, if you have 10 more objects referencing to the user, one of them changes. For all the 10 different objects in the stack, this particular change will be visible. So the final truth is reassign references no effect, but when you mutate the object, then the visibility is everywhere for all the variables where you are trying to get the variable or the heap memory. So I'll give you one very simple analogy. You and your friend lives in the same house. Your friend moves to the new house. You still are at the old house, and that is what Java is all about. Your address changed, but your house still remains the same. You still exist at the same address only. The only address is changed for your friend. So it is by default passed by value. Only the address is copied from one place to another. That's it. So that was how I proved Java was passed by value and not passed by reference. Now a third very important part. I'll again copy this code here and let's discuss about a very common misunderstanding about equals and hashcode. So if two objects are equal, their hashcode must be equal, and this is non-negotiable. So if you override the equals and say the two users are equal, say user 1 and user 2 are equal, if their IDs are equal, this is not possible with just one method overriding. What you have to override for sure is the hashcode method. So if hashcode is not implemented correctly, your hashmap behaves inconsistently, your data disappears silently, and bug occurs in the production without any compilation error. This is the biggest problem I see in the production when you override the equals but you forgot the hashcode overridden. The non-negotiable contract rule says that if two objects are equal and you think they are equal in the business requirement, then hashcode must be equal. Otherwise, your object will be lost. Reverse is not always true. Hashcode may be different or hashcode may be same, but the two objects might not be same or equal. That is when the case that you will have the collisions. I'll tell you everything in detail. Why equals exist is for equality. Remember why equals exist and why hashcode exists, okay? If two objects represents the same real world entity, then you call it equals. So if these two are users, then u1 dot equals will return true because they have the same id. But why hashcode exists? Hashcode does not talk anything about equality. Hashcode only talks about the lookup, the faster lookup in the collection, like hashmap, hashset, or concurrent hashmap. These collections do not search everything. These uses buckets. So to have the faster lookup into these buckets of hashmap, hashset, or concurrent hashset, you need a hashcode. So if you don't add u1 and u2 to the same bucket, and if by any chance u1 and u2 are stored in two different buckets, and you try to get them, and the hashcode is not properly implemented, you will not get the proper bucket number where you have to search it. And if you go to the wrong bucket and you try to search your object there, you will not find it. You will get result as null, and your object is hanging somewhere in the whole stack or bucket of the hash map, and you will be in trouble. So when you do hashmap.put key value pair, what happens? First, a hashcode is called. Hashcode converts to the bucket index. The object is stored into that bucket, into that particular bucket index. And if it has already the entries there, then equals is used to fetch the exact match when you do the get object operation. So this is the put operation where the hashcode is calculated. And at that particular bucket, if there is a collision happening, maybe a linked list is created or tree is created, but on the same bucket number in a list format, you have multiple objects saved. When you try to get an object, that is map.get the key, then again hashcode is calculated. Then the exact bucket number is found, and onto that bucket number it tries to fetch the user with the key, and the dot equals is used to compare the key part of the bucket stored into it. So that is why hashcode is very important. But what if you just override the equals and you forgot the hashcode overriding? Don't worry if you think this is something you know, but this is going to be used when I'm going to talk about Lombok and the disaster what Lombok does in the production environment, and why Lombok is a disaster in production environment if done incorrectly with a @data annotation, which we are going to discuss in 2 minutes. So a step-by-step failure, if you have not overridden the hashcode, what happens? You start putting the object u1 with a new data or a into the bucket, then you fetch the hashcode. For the u1, the hashcode comes as 100. Now, the visual picture, if hashcode was implemented properly, what would happen if you try to put u1 and u2 into picture? So the u1 would have id1 value as data, the lookup key. Now when you try to put or get u2, when you try to get u2, the id says 1. So it says by default, the value for u2 should also be a. Because when you put u1 into the map, it puts key value pair as 1, a. Then when you try to put u2 into the map, it searches for 1. Then it sees, oh, these two objects are equal. It is going to override a with b. So when you try to get anything with map.get1, you will get b and a will be overwritten in the hashmap case. So if hashcode would have been properly overridden, when you try to search u1 dot equals u2, it says true. And whenever you try to get u2 dot map dot get u2, you would get a return value of a. But what if you have not overridden the hashcode itself? Like the code here in the user object. You have overridden equals when saying that user1 and user2 are equal. But hashcode is not overridden. What will happen? Now, this is where the disaster occurs. Okay. So u1 is put into the into the map with 1 a. Then you do map dot put u2. That it fetches the hashcode. It gets as 1. So it goes to the bucket number 1 and sees, okay, 1 is already present. Is u1.id equals to u2.id? It says yes. So this is the object that I want to put into. So it is going to override that object A with object B in the value of that entry object. So now u2 will also point to the same bucket, that is 100, and value as B. But if hashcode was not properly implemented, you do u2.hashcode. When hashcode was not overridden, it gives a different bucket number, say 900, and not 1 or 2 or 100 as earlier where u1 was stored. So u2 was stored at bucket number 100, but hashcode gave you a different bucket number as 900. So you go and search into 900 and you say empty. So even though u2 was present into the map with a value as b, you will return null and your data is lost. And this is why hashcode is very important, because otherwise your data is disappeared. Data exists in the map, but lookup goes to a different bucket. No exception, no warning, no runtime failures, no compile time failures, but your data is lost. How it would have been better if you implement the equals and hashcode in this way. That's why the same hash works, and it works in hash collision also. So what breaks the hash map logic is when you make the two objects equal, but their hash code is not equal, then 100% your data will be lost in the map. So hash code decides the bucket, equal decides the match. Remember the difference between hash code and equals. For equality, you have equals, but deciding the bucket where you have to store or get the data is what is decided by hash code. So for sure, your hash code should remain same if your objects are equal. So if objects are equal and they do not share hash code, then the hash map logic is broken. The lookup never reaches the equals object. It will even try to get from the different bucket location, and you will be in a disaster situation where even though you have the object stored, but since you have not the proper bucket number, you will not reach to the right place and you will not be able to get anything from the hash map, even though object was there onto the hash map. So remember to have the proper hash code implemented. Now, last but very important thing, we all use Lombok. Who writes getters and setters for 100 fields in a Pojo? What disaster we do is with @data. Why do we do @data? So that we don't have to write @getter, @setter, toString separately, right? You never know what disaster this @data will do in the production. And I'll tell you why. And everything is related to equals hashcode and toString again. So it silently generates behavior that you do not even want in your Pojo. For example, I have a user class. I'm going to copy this as a code reference for coming up discussions. So now this user has two fields, ID and name. Now behind the scene, Lombok does a beautiful job. When used @data, it generates a lot of things. And you can't even imagine what all it generates. It generates getters, setters that you want. It generates toStrings that you want. The disaster happens here. It also generates equals and hashcode. And what is a disaster? The disaster is when it overwrites equals and hashcode. It considers not just the ID but also the name of the person to match the similarity of the two objects. And if you have 100 fields, all the 100 fields will be used for comparison for the equals and hashcode. So if you want user 1 and user 2 to be equal, by the business rule, yes, user 1 and user 2 should be equals because they exist with the same employee ID or the user ID. But because of your @data, they are not equal. Because the hash code contains the logic for both checking not just the ID but also the name of the user. And why is it dangerous? Because ID is always stable. It is always the identity, but name is mutable. It can change. I can change my name to code from code to decode. So this is completely mutable. So one code also points to the same object as one code decode. But the production bug lies when hashcode was calculated with the name also. So your name changed from code to code decode. So your hashcode also changed. And now since your hashcode changed, you try to find 1 comma code, which should be now 1 comma code decode. You try to search on the hashcode bucket. You get a different hashcode because your name changed. Because what wrong you did is you generated equals in hash code automatically by Lombok. And Lombok considered not just ID but also name while considering these two objects same. So now Lombok says U1 is not equals to U2 because their names are different. So when you try to search U2, it should have been overridden with the name as code decode, but it doesn't. So hash code change, object is now in the wrong bucket. They are not equal anymore. Object exists but still cannot be found. The silent data correction that I've told you 2 minutes earlier in the code, in the video. So that was the first disaster that you have already done with data, because you have unwantedly overridden equals and hash code with the wrong fields, where you should have just considered ID for equality in hash code generation. Your business logic is not known by Lombok. How would they know that only ID should be used? It used ID as well as name both for the equals and hash code comparison, and that is where the disaster happened. The second is mutable fields is used in hash based collections. You remember, whenever you want to calculate a hash code or equals, it should be on the immutable fields. So hash code remains stable when the object is immutable. But data, at the rate data breaks this assumption, because suppose you have any field which is mutable and you have used that in the calculation, then you are in disaster. This also causes the hash map to return null. It leads to memory leaks, because even though your object is there, you cannot reach it, and those are called as ghost entries that you cannot even reach to. Then how will you remove it? The third disaster that you do with at the rate data is, by default, it also implements toString. Now suppose you have user with username and password. You used at the rate data over it. What is not visible is you have used at the rate toString also over it. So in the list, if you see, getter, setter and toString is used. Now since toString is also used, when you print the user object, you see username as well as password, which is a secret leak. So accidentally, not even knowing that you have used toString, you have used at the rate data, but when you print anywhere the user, your security incident happens because your password is leaked in the logs. Fourth, rarely occurring situation, but can be possible. Suppose you have an e-commerce website, you have orders with who has placed this order is a user. Now when you have a user, it can place the list of orders. So this is a bidirectional utility. Now when you try to use at the rate data on both of them, it internally uses toString also. So when you try to write an object order, it tries to search for the user object, and since it also has the toString, it tries to search for the order object. It goes here, it has toString, it tries to search for the user object and print the user object. User object tries to print the order object. And see, this is how you go into unlimited Stack Overflow error, because this is an infinite loop that you have done here with the disaster of having at the rate data of Lombok. The last part, business says user 1 and user 2 are same, because user 1 with ID 1 name code and user with ID 1 and name code decode with the last name imported. The business says both are same users because their ID same. Lombok does not know your business logic, right? How will it know about it? So at the rate data says, no, they are different object, because I'm going to consider each and every field for equals and hashcode comparison, which breaks caching, which breaks your business rules, which breaks your checks, deduplication, everything is. So when data is actually safe, when you have immutable objects, when you are not going to store it in Hashmap and no bucket kind of logic will be there, when no sensitive data is there, otherwise toString will expose it, and it should be short-lived. So the best way is either you make that immutable, or the second option is you can have the explicit control where you use only what you want to use. Don't use at the rate data. Use at the rate getter, at the rate setter, at the rate toString with excluding the password, so that the password is not printed when you print the user object, and you can use only explicitly include the hash code, and in the hash code and equals only include ID, and do not consider name and password for comparison of these two objects and finding it onto the hash code. So at the rate data is, yes, very dangerous for domain entities, because it includes mutable fields like equals and hashcode, which breaks the hash based collection and silently produces lots of production bugs that you won't even know that your at the rate data was a reason and for the Lombok for your code to break at the runtime. So I have many more things to cover. Why formula never always execute? Why don't you understand that the collection under hood does a lot of different things? How do you misuse the volatile keywords? And a lot of things we do wrong in a Java interview. So let's get started with these topics once I get the confirmation for you in the comment that yes, this was useful. And if you comment, I should create the second or third part of it, let me know in the comment section. Then only I'll create it. If you know all these concepts and it is not very useful, then leave that part. That's okay. Thank you so much.